Okay, students, so now we are going to start a mock interview for our student Tanveer. And this mock is for quantum technology specialization in IISc Bangalore. So Tanveer, first of all, you introduce yourself.
Sir, I have done my B.Tech from Institute of Engineering and Management, and my background is from electronics, and so I am interested in this quantum technology department because there is a lot of application of electronic devices on the field of quantum. So that is my motivation.
Okay, so did you apply in any other program also?
In IISc, sir?
Yes.
Yes, nanoscience and instrumentation and applied physics.
So what is your first choice?
This on quantum technology.
Quantum technology. Okay. So what is the scope of quantum technology? Any idea?
Sir, actually, there are big tech giant companies like Google, Intel, and Texas Instruments all are investing. And currently in India, also TCS and Capgemini have started their investment in quantum technology. So there is a industrial application there will be in future, and at the same time, there is a lots of research scope in this field. That I think.
Okay, so what is your future plan? Means
Hmm.
in future, what do you want to do?
Sir, I would like to go for research in this field.
Okay, so you are ready for pursuing PhD?
Yes, yes, sir. Yes, sir.
So did you apply in PhD program at IISc?
Sir, this department does not have any PhD program, but I have applied in MTech research for nanoscience and applied physics, something this type.
Okay. Uh, Tell me what is a random variable?
Sir, it's a actually sir variable that takes value randomly from an event. That's random. For example, sir, we are throwing dice and and sampling its value like 1 or 2 3 4 5 6. So the if the dice is totally unbiased, so there is a equal probability that it can be 1 or 2 or 5 or 6. So it can be take any value. It will not follow particular function. So it will be take randomly any value.
Okay. Okay, we have a function fx equal to
Hmm,
e to the power modulus of x.
hmm, hmm,
Can you draw it?
hmm. Uh, Sir, at x, okay,
E
sir,
to the power mod x.
it will be the mod
ग्राफिकली
x.
ड्रॉ करो इसको.
Okay. Sir,
This is e to the power mod x.
mod x.
Okay. Now you tell me, is this function differentiable at x equal to 0?
On no, sir, it is not differentiable at x equal to 0.
Why?
Because that when will we do the derivative, derivative of the mod x will be, sir, for x greater than 0 it will be 1, for x less than 0 it will be minus 1. So for this mod x term it will be not differentiable at the point 0, but any other point it will be differentiable.
Okay. We have a relation y equal to sine ax plus b.
Y equal to sine, okay.
Sine of ax plus b,
Hmm.
where a and b are arbitrary constants.
Hmm.
So if we change a and b, we will get different curves.
Hmm.
So we will get a family of curves.
Hmm.
Can you represent this family with the help of a differential equation?
Hmm. Hmm. Oh, I can, sir. So,
Do it. What is this? D square y upon dx square equal to?
Some constants are minus k into y.
So what is this constant here?
So this constant is this constant will be sir frequency of the signal, that is sine of ax over omega square equal to that k will be sir omega square actually. So basically it is the a square, k equal to a square.
Okay. Now we have a matrix that is of size 3 by 5. What can be the possible ranks of this matrix?
Okay, 3 by 5 possible ranks. It can be sir 1 2 3.
1 2 3, not more than 3.
Not more than 3. Sir.
Sure.
Yes, sir.
Okay. And what is rank nullity theorem?
Rank nullity theorem, sir. So I guess that there is a, if there is an equation like ax equal to 0, where a is a matrix and x is a vector, from there sir nullity of the space is sir number of column minus rank of the matrix. That is the free variable, number of free variable of that space.
Okay. What is method of separation of variables?
So method of separation variable we use in solving partial differential equation, for linear partial differential equation, precisely speaking. So for example, there is a linear partial differential equation in two variables like position and time x and t. So and that is a linear equation. For example, so there is a wave equation, that one is a linear and partial differential equation. So to solve that equation, what we can do, sir, we let the function, the solution is a multiplication of two functions. One is position and time, or then sir putting that solution, assume solution in the equation, then we can we can differentiate it. One side is position dependent function, one side is time dependent function, so both will be individual constant, and then we can solve the equation more easily, quickly.
What is difference between PN junction diode and Zener diode?
Okay, so PN junction diode, and Zener diode both can operate in forward bias, but in reverse bias case, sir, PN junction diode in the reverse bias, in high reverse bias voltage, it will break down, but Zener diode will be work. Zener diode will show the Zener action in the high reverse bias voltage.
Okay. Any application of Zener diode?
Yeah, voltage regulation.
So how it regulates the voltage?
Okay, sir. In Zener breakdowns, what's happened, that VI curve is totally steep. It means it can allow very large amount of current with a small change in voltage. So whatever the increased current of the input that it can allow, but its terminal voltage will change very small amount. So that's the main funda, that Zener diode can regulate our output voltage.
Okay. Jyoti ma'am.
Okay. So can you tell me what do you mean by quantum mechanics?
So basically, there is a two mechanics. One is classical mechanics and quantum mechanics. Classical mechanics is based on Newtonian equation and the classical Hamilton equation. So it's all about the big object that we can see, like ball, football, car, everything. But when you talk about the atoms in the atomic size or in the nanoscale, the particles follow different rules, and that rules is basically quantum mechanics, the mechanics of the small particles.
So what do you mean by quanta?
Quanta is a basically it is the quantization of energy, that there is some value which will be multiplied, that particular value is the quantizing, actually, that is the quantized energy, that is the quantized.
What is that value?
That is h cut omega. That is a packet.
Can you explain the black body radiation and its explanation using quantum mechanics?
What one? Please explain.
Can you explain the black body radiation?
Oh, black body radiation. Yes. Black body is the body that which absorb every radiation. So according to the thermodynamics law, it will also radiate at every frequency. So the curve is something like,
How it is explained using quantum mechanics?
okay. So in basically if we derive the black body radiation according to the classical physics, what the result what we get is that it will radiate infinite amount of energy, but experimentally that is not the true. It's always radiate finite amount of energies, and uh, in the higher frequency that power spectrum is low and lower frequency, something like that types of curve. So what Planck did is that he assumed that that in the world of the black body, every atom cannot amount any arbitrary any frequency. It can only amount some h cut omega or its multiple amount of frequency. So he used that term, that is e to the power h cut omega minus one something in the numerator. That's integration.
Fine. Can you tell me what do you mean by Schrödinger equation? Like what type of, what is its physical significance of Schrödinger equation?
Basically, in quantum mechanics, what happens, there is a very important parameter, that is wave function, because that modulus square of this wave function gives up the probability density function of finding a particle, and that is the everything that starts in quantum mechanics. So to find that wave function, we need a mother equation, and that is the Schrödinger equation. So basically, solving Schrödinger equation according to the potential, wave, and variation, we get psi with the boundary condition we apply, and then we get the psi, and from that we can calculate every average energy or average position, something like. Or
if we want to find the position of any particle, can you show me how you will do it using the wave function in the integral form?
But can you specify some potential from?
Just the integral form of finding the expected value of position.
Oh, okay, yes. Ma'am.
So you have taken minus infinity to infinity x and psi x square. So instead of psi x square, it will be psi star psi, right?
That is also written in first.
Okay, fine. I was not able to. Fine. What we will use when we want to find the potential?
Find the potential. I mean,
momentum. For momentum, are you aware of the operators?
Okay, yes.
Okay, fine. Similarly, there are other operators also for energy.
You can make the P square by 2m means energy.
Right. So, are you aware of wave packets?
Yeah.
Can you tell me what is phase velocity and group velocity?
Okay, ma'am. In phase velocity means the at what velocity phase of the wave is changing. But group velocity is the velocity of the envelope. At what velocity the envelope is moving. That is the group velocity, and these two are always not equal. Yeah, for simple wave, that is Vg equal to Vp, but in complex wave envelope, that is not always equal. So
can you tell me the formula which related to omega or G for both?
That is the relation, but I can say that group velocity is omega by k, and Vp equal to partial derivative of del omega by del k, and I can also derive, but it will take some time to. But I mean, Vg equal to Vp, there's a relation, yeah, according to lambda, that you want.
No, I'm just asking the relation. You don't have to derive. What about Vp? Vp is equal to what? Phase velocity.
Phase velocity. Yeah.
is equal to what omega in terms of omega and
Vp equal to omega by k, and Vg equal to del of omega by del of k.
T. So, can you tell me that why the intensity does not increase in photoelectric effect even when we are increasing the frequency?
The
Frequency.
okay, so, I mean the current does not increase. That you are asking, ma'am.
Yeah.
Ma'am, in photoelectric effect, we have to consider that the electron is the energy is photon. So increasing frequency means increasing the particular wave packet energy per wave packet energy, that is HF, and we are increasing the number of photon that is falling on the electron. So if we increase the light intensity, so it will increase the number of photons that will generate more free electron that will generate more current. That's the thing.
I'm just saying that until and unless it does not reach any particular frequency, there is no increase in the current, or we don't observe any current.
Yes.
Why is
Okay.
that?
Okay. So basically, basically what happens in quantum mechanics, the energies are discrete. Now, electron will absorb a photon packet only if it can go to the next level. Otherwise, it will not. It will totally reject that photon. Now, so basically, for every matter, there is a particular energy gap to that the electron have to cross. So there is a threshold photon energy that the photon should have. Otherwise, the electron totally reject that photon, and it will not actually work. Photoelectric will not be happening. That is the reason.
It is equal to work function, basically.
Work function, yes.
Right, that's it from my side. Sir?
Anything?
Can you tell me difference between interference and diffraction?
Okay, that question, ma'am. Okay, first difference is that in interference there is two different sources that is involving, and in different in diffraction there is 2 point of the same wavefront that is involving in this experiment. And in interference, the intensity of the different fringes is same, but for diffraction the intensity of different fringes totally decayed as we go from the center towards the dark lighting side.
One last question. Can you derive the Schrodinger wave equation?
And the television, I should I did not see.
Can you derive the point of like so in young double slit experiment where the two waves are meeting and where there is maxima? Can you derive for that?
Okay.
If the distance between two sources is small d and the distance between screen and the source is capital D. The diagram. Solve.
And for maxima, I have derived that is for maximum, and minimum that is.
Just put your fine. That's all.
So anything I record to add more in quantum mechanics or something in physics?
I think for quantum mechanics you have already prepared a lot, and I think it's your third mock, right?
Mhm.
It is your third mock, right?
Yes, ma'am.
You are giving this interview for the third time, right?
Yes, ma'am. I'm giving her time.
I think from quantum mechanics point of view, you are good other points of.
Ma'am, ma'am, should I prepare coding, because I am from EC background and I am not good at coding actually.
If you're not from coding background, then they won't ask. But if you're from computer science background, then they will ask. They can ask you the maths question and also from your background.
Okay.
Like you have mentioned, you have studied tunneling diode
Hmm.
in your earlier interview. So they can ask you regarding tunneling also. So either avoid mentioning it, and if you're mentioning, then be prepared.
From in math, ma'am, anything? I mean, sorry, sir.
Maths sir will tell you.
But why, sir?
I think there is some issue.
हेलो
Yes, sir.
हाँ भाई, आपका क्या नाम है?
Sir, Tanvir, sir.
देखो यार, एक तो ईडीसी के बारे में थोड़ा नॉलेज रखना है।
Yes, sir. Okay, sir.
ठीक है, तो आपने कर लोगे आप, मेरे को जहां तक लग रहा है आपका। ठीक है,
Okay, sir. मैथ में कुछ
बेसिक
सर?
क्वेश्चंस मैथ में सिंपल प्रोबेबिलिटी।
Yes, sir.
और ग्राफ्स।
Okay.
और डिफरेंशियल इक्वेशंस
हम्म।
और लीनियर अलजेब्रा। इनके अंदर से कुछ भी बेसिक क्वेश्चन बन सकता है।
Okay.
बहुत ज्यादा टफ नहीं होगा, नॉर्मल क्वेश्चन ही होगा, पढ़ा हुआ होगा कहीं ना कहीं, उसको ध्यान से सुन के समझ के आंसर करना है।
Okay.
ठीक है, जैसे आप तुमने ऑलमोस्ट सभी आंसर ठीक दिए हैं।
Okay, sir.
ठीक है।
Okay, sir.
और जो फिजिक्स में मैम ने बताया है उन टॉपिक्स को एक बार प्रिपेयर कर लो। और
Okay,
इलेक्ट्रॉनिक्स से भी पूछा जाएगा, बेसिक तुम्हारा ईडीसी के बारे में कुछ ना कुछ पूछ सकते हो, क्योंकि नैनो में तुमने इंटरेस्ट दिखाया ना अपना। हाँ, तो उसमें आपसे कुछ ना कुछ जरूर पूछेंगे वो।
Okay.
सेमीकंडक्टर फिजिक्स जो होती है ना, उस सेक्शन को कंप्लीट कर लो।
Okay.
चलो,
Okay.
ऑल द बेस्ट।
Thank you, sir. Thank you, ma'am.